Hello class, and welcome to today's lesson. Our topic for today is series, arithmetic, geometric series involving compound numbers. So we're talking about arithmetic series. We'll be dealing with geometric series and how it relates to compound interest. So we're talking about series. You would have been given an arithmetic sequence for the series. So given an arithmetic sequence with the first term A, you know that an arithmetic sequence we do with first term A and also do with common difference, which we denote as D. You can recall that the nth term has this formula AN equals to A plus N minus 1D, where N is known as the number of terms. So N stands for 1, 2, 3. It could be up to 100. Yes. So n is noted as the number of terms. Now, if we are defining the nth term arithmetic series, that means we're talking about the sum of the first n terms of the arithmetic sequence. So, let's say you've been given an arithmetic sequence A1 to AN. If you're talking about arithmetic series, you're talking about the sum Sn, which is the sum of the several terms there, which is A1 plus A2 plus A3 up to AN. So now I want to derive a simple formula for Sn. So we know that Sn, which is A1 plus A2 plus A3 plus up to AN, yes. We know that this one means that some terms in between. Okay, so we know that A1, which is the first term, can be denoted as A plus 0D. How did we get this? If we come back here, we have A plus N minus 1D. If it's A1, that is A plus 1 minus 1. 1 minus 1 becomes 0, so 0D. So A2 will now be A plus 2 minus 1D. 2 minus 1 gives you 1. So A2 will be A plus 1D. And then we continue like that. A3 is A plus 2D. Continues up to AN. AN can be written as A plus N minus 1D, which we have written here before. A plus N minus 1D. Now we are going to reverse the order. We will write it in a reverse order. So for this one is going to be our first equation, so equation 1. Now when we reverse the order, this one comes first. Sn will now be A plus N minus 1D plus the one that will come before this would have been A plus N minus 2D plus A plus N minus 3D. Remember, the reverse form is we're starting from the back instead of from the front. So we have left the front, then we're starting from there. Then if we trace it up to this point, this one is A plus 1D. So the first becomes last and the last becomes first. So A plus 0D. So we'll make this one our second equation. Now we add equation 1 and 2 together. So we have Sn plus Sn gives us 2Sn is equal to, here we have A plus 0D. If you add it to A plus N minus 1D, this one becomes 2A. Am I right? A plus A becomes 2A. Then this one becomes what? N minus 1D, because 0D is out. So this becomes 2A plus N minus 1D plus, we pick the next one. A plus A gives us 2A. N minus 2D plus 1D. If you add it together, you are still left with 2A plus N minus 1D. Now, if you continue with this, we keep on adding it, keep on adding the terms together in these two equations. Everything will still give you A plus 2A plus N minus 1D. So we have 2Sn is equal to, so it's going to give you n times. So if you have 10 terms here, it's going to give you 10 of this 2A plus N minus 1D. So we have n of such but we don't know how many terms are here. We note it as n, which is the number of terms. 2a plus n minus 1d. If we divide both sides by 2, our Sn becomes n2a plus n minus 1d all over 2. So I've gotten the formula for sum of terms, which is the formula for the arithmetic series. So another easy form of this Sn is that we can rewrite this Sn. Remember we wrote it as n into bracket 2a, so that's way we can divide it as a plus a. We can split it actually. A plus a plus n minus 1d all over 2. And we know this part a plus n minus 1d can be denoted as what? An. Remember what I said? We denoted this one as an, which is the nth term of the whole of this. So over 2. Here this one is the first term and this one is the nth term, which some people call the last term. So this is another formula for the arithmetic series or for the sum of terms. So now we move to the geometric series. Under geometric series, we also deal with first term, which we denote as a. Then we deal with common ratio, which we denote as r. So yeah, we don't deal with common difference. We deal with common ratio. So we can recall that in a geometric sequence, we have the first term a and the common ratio r. So to get the nth term, we have it as a r raised to power n minus 1. Where n is also number of terms, 1, 2, 3, and it goes on like that. So it could be 1, it could be 2, it could be 100. So now if we want to get the nth term geometric series also, it's also the sum of the first n terms. So the same thing here, same thing applies here. The sum of the terms of the geometric sequence is going to give you the geometric series. So up to the nth term. So we have it like this. Now we can also derive a simple formula for this sum. So remember that this is the geometric series, sum of the n terms of the geometric sequence. So the first term is a. The next term here, we write a2 here. A2 is what? It will be a r raised to power 2 minus 1, which is a r. You can say a r raised to power 1. So this is a r. The next one is going to be a r raised to power 2 minus 1, which is 2. It goes on and on like that until you get to a r is power n minus 1. Yes. So now we multiply both sides of this first equation. We're going to make this one our first equation. Multiply both sides by r. It gives us rsn equals to ar plus ar squared plus ar is power 3 plus dot 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 plus ar is power n minus 1 plus ar is power n. So this becomes our equation 2. Now I want you to subtract equation 2 from equation 1. So you subtract equation 2 from equation 1. Yes, what are we going to have? So let's subtract equation 2 from equation 1. Okay, so we subtract equation 2 from equation 1, and then we have Sn minus Rsn. Now gives us a plus ar plus ar squared plus dot 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 plus ar is power n minus 2 plus ar is power n minus 1. This is equation 1 minus equation 2 plus ar is power n minus 1 plus ar is power n. And we subtract everything, we'll be left with Sn minus Rsn. Remember there are some terms in between, so by the time you subtract, we only have the first a minus the last term ar is power n. So if we have this a is common, we bring out a 1 minus r raised power n. So here we also have Sn common, 1 minus r. We divide both sides by 1 minus r, we are left with Sn. Now be a into bracket 1 minus r raised power n over 1 minus r. So this gives us the formula for the sum of terms in a geometric sequence, which you can also call the geometric series. So now we move to compound interest. Compound interest, yes. We talk about compound interest. It's a very, very interesting application of geometric series. Yes, and it's very important. It's not just interesting, it's important. So it's an important application of geometric series. Now we talk about compound interest, then we're talking about the process of adding and interest to the original amount of an investment. So for example, now if you invest $10,000 probably in a company, in a limited liability company, if you invest this amount, $10,000, with the hope or with the knowledge that your interest will be compounded annually, then you know that this is compound interest. But if it's just simple interest, then you know that at the end of maybe n years, n, which means the number of years, you know that you get probably some money added to your original amount. But for compound interest, it is compounded annually, and then you earn interest on even an interest that has been earned. So for example now, if you should invest this $10,000 in a company and it's compounded annually, then at the end of the first year you have maybe you earned $115 on this $10,000. So you know that your total amount at the end of the first year is $10,115. Am I right? Now, in the coming year, for the second year, let's say you left that money to be invested in the company for 5 years. In the second year, your interest is not going to be calculated on the amount that you invested again. It is now going to be calculated on the new amount. So this new amount now is $10,115. So you will now be earning interest on this amount. So at the end of the second year, maybe you get another interest of $225. So by the time you add it together, you have $10,340. So by the third year now, you get to calculate your interest. It's going to be based on this amount. So that's why compound interest is so interesting. So because it's dealing with common ratio. So like I said, now we decide to invest this amount annually. You know that the accumulated amount at the end of each year now becomes the amount that will be subject to yield interest at the beginning of the new year. So that's like compound interest is a very interesting aspect of geometric series. So now if you invest an amount X now for n years at the rate of interest I, you know that interest, the unit for interest is a percentage. So and this interest compounded annually. At the end of the n years now, we are expecting this amount 1 plus I% raised to power n. So we are expecting this amount. Where this I%, you know, for percentage divide by 100. So if it's 5%, this is x into like 1 plus 5 over 100 is per maybe for 10 years. You include the money for 10 years or 9 years. So you have something like this. So by the 10th year, the beginning of the 10th year, you can see that you have gotten a compounded amount for 9 years. So by the beginning of the 10th year is the amount that you got at the end of the 9th year that your interest will be calculated based on. It's not going to be calculated based on the amount that you invested originally at the beginning of the first year. So compound interest is really, really interesting. It's actually a very, very good way of investment because your money is being compounded and it grows exponentially. Even though at the beginning it might be a bit slow, the growth rate might be a bit slow, but with time it goes up. But for simple interest, well, at the beginning it might look like okay, all is well, all is up and good, but the growth rate might not really increase as time goes on. But for compound interest, we have an exponential growth rate in the coming years. I've come to the end of this lesson, and I hope you've been able to gain a few points that will help in the next journey. So I'll see you in the next class, and I hope you enjoy the rest of your day. Bye.